So friends, in this video I will explain three scenarios, and for those three scenarios how much force is necessary. In the first example, we will see how much force is needed to lift the object of mass m. In the second scenario, we will see how much force is needed to move this object in upward direction with acceleration a meter per second square. And in the final scenario, how much force is necessary to decelerate this object in downward direction with deceleration of a meter per second square. So let us talk about the first example. So in this case, on this block is basically hanging, right? So there will be a downward force, and that force will be mg. So if you just want to lift this object, you will need at least the force that is equals to mg. So if you apply the force that is less than that, then object is not gonna get lifted. You will need at least this force plus small extra force to lift it. Okay, mg plus, we can say. Now in the second example, let us say you want to not just lift this object but move this object in upward direction with the acceleration of a meter per second square. So force is given a mass into acceleration. So acceleration is given as a, so I have taken a over there. Mass is also known, it is m. If you apply this force on the object, that will accelerate with the a meter per second square. But here what is happening is that there is a downward force, right? So we will need this force plus that downward force as well, that is mg. So when we are moving this object in upward direction with acceleration a meter per second square, the tension in that rope will be m into a plus g. Now let us talk about the third scenario here. The object is decelerating with deceleration rate of a meter per second square. So in this case, we want to move in a downward direction. So basically, the same force we will need, mass into acceleration, but there is downward force of mg as well, right? Mg is also in the downward direction. So basically, that gravity is helping us come down. So we will need to subtract that, and that's why the tension in that particular cable, this cable tension will be, so actual force or the tension in that cable will be m into a minus g. So if you compare this scenario so if you compare the second scenario with the third scenario, you can easily see that if you want to move in upward direction, then you will need more force as compared to the third scenario. Because in the third scenario, what is happening is that gravity is helping us, and that's why we will need less force. Thank you for watching.